The binomial theorem is a formula used to generate the expansion of a binomial raised to any power. Because the formula itself is very complex, we will look at it more closely in the next few slides. What happens when you multiply a binomial by itself n times? Let's evaluate. Alright, so a plus b to the 0 power, well, anything to the 0 power is 1. A plus b to the first power is just a plus b. A plus b squared is the same thing as a plus b times a plus b. So using FOIL, we get a squared plus 2ab plus b squared. And here we have a plus b cubed. So that gives us a cubed plus 3a squared b plus 3ab squared plus b cubed. Let's look at the final result. Do you notice a pattern in the exponents? The exponents of a decrease by 1. A cubed, a squared, a to the first, and then a to the 0. And the exponents of b increase by 1. B to the 0, b to the first power, b to the second power, b to the third power. The sum of the two exponents always equal the original power 3. So a to the third times b to the 0, 0 plus 3 is 3. Here we have a squared times b to the first, 2 plus 1 is 3. Here we have a to the first power, b to the second power, 1 plus 2 is 3. And here we have a to the 0 power times b to the third power, 0 plus 3 is 3. Each term has variables and exponents, a to the n minus k times b to the k, where n is the exponent from the original problem, and k is the term number beginning with k equals 0. So here, k starts at 0, so our first term is a to the n minus 0, so a to the third. Here we have k value of 1, so that gives us a to the 3 minus 1, which is 2, times b to the first power, because k is 1, and so on. Remember, a to the 0 equals b to the 0, which equals 1. Let's try a few more. Expand x plus y to the fourth. I'm going to move this out of the way to make some room. Alright, I'll move this over here. We can get started by imagining this as x plus y times x plus y times x plus y times x plus y. So the first thing I'm going to do is just multiply this binomial by this binomial. And that gives us x squared plus 2xy plus y squared. And that's this one times that one. Now this times this is going to give us the exact same result. So we can just multiply that here. X squared plus 2xy plus y squared. Now we have to multiply these together. So we begin with our first term here, x squared, and I'm going to multiply it by each of these. So x squared times x squared is x to the fourth, plus we have x squared times 2xy, so that's 2x cubed y, plus x squared times y squared. There we go. Now I'm going to move on to this term here. 2xy times x squared is 2x cubed y. 2xy times 2xy is 4x squared y squared. 2xy times y squared is 2xy cubed. Now I'll move on to the third term. Y squared times x squared is x squared y squared, plus y squared times 2xy is 2xy cubed, plus y squared times y squared is y to the fourth. All right, so now we simplify. We only have one term that has x to the fourth. Now, how many do we have that has x to the third times y? We have one there, and we have one there. So when we add those together, there's two of them there, two of them there. That becomes 4x cubed y. All right, next we have x squared y squared. We have that there. We have 4 of them there. And we also have another one over there. So 1, 2, 3, 4, 5, 6. We have 6x squared y squared. Okay, moving on. We have 2xy cubed. We have 1 there. Well, we have 2 there and 2 there. So that is 4xy cubed plus y to the fourth. So this is our answer. All right, and there is our solution. Now we want to expand x plus y to the fifth. Since we've already done all this work, look at this. X plus y to the fifth is the same thing as x plus y times x plus y to the fourth. So we can just take this whole solution here and plug it in there. So all we have to do is multiply this by x plus y. All right, so I'm going to erase all this, and I'm going to move this out of the way. Get rid of that. All right, and so now we just need to multiply this by x plus y. So x times x to the fourth is x to the fifth plus 4x to the fourth y plus 6x cubed y squared plus 4x squared y cubed plus xy to the fourth plus, now we're going to multiply each term here by y. Y times x to the fourth is x to the fourth y plus 4x cubed y squared plus 6x squared y to the third plus 4xy to the fourth plus y to the fifth. Now we need to simplify this. We have 1x to the fifth term, so that's just x to the fifth. Now x to the fourth y. X to the fourth y, we have another one there. So we have x to the fourth y. Okay, so we have 5 of those. 4 plus 1. 5x to the fourth y plus, all right, we have x cubed y squared. X cubed y squared here. So we have 6 there and 4 there, so that's 10x cubed y squared plus, all right, we have x squared y cubed. X squared y cubed. We have 4 there and 6 there, so that's 10x squared y cubed plus, all right, we have x times y to the fourth, and we have 4xy to the fourth, so that's 5xy to the fourth plus y to the fifth. So here is our solution for x plus y to the fifth. And there you have it, our solution. Now let's look at the coefficients. Here we have a plus b to the 0 power equals to 1, so the only number we have is this coefficient 1. A plus b to the first power is a plus b, both of which have a coefficient of 1, so we have 1 and 1. A plus b squared gives us coefficients of 1, 2, and 1, 1, 2, 1. A plus b cubed gives us 1, 3, 3, 1. A plus b to the fourth is 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Do you see a pattern? Can you continue the pattern to add 2 more rows? We call this pattern Pascal's triangle. To get the next row, we start and end with 1. Then add the 2 numbers above the next terms. Fill in the next 2 rows. All right, so the next row, we're going to start and end with 1. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So this is our 5th row. To get our 6th row, we start with 1. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. Then we have 15 again, 6, and 1. So we have the 5th and 6th row. One way to find the coefficients when expanding a polynomial raised to the nth power is to use the nth row of Pascal's triangle. Now that we know how to find the exponents and the coefficients when expanding binomials, let's put it together. Let's expand x plus y to the 6th power. Focusing first on the exponents, we begin with x to the 6th, y to the 0 here. Then the exponents for x decrease 5, 4, 3, 2, 1, 0. And the exponents for y go up from 0 to 6. Y to the 0, y to the first, second, third, and so on. The coefficients are going to follow the 6th row of Pascal's triangle, which is 1, 6, 15, 20, 15, 6, and 1. Once you simplify this, for example, that goes away, and so does that one, and you don't have to write the first power. Here it is simplified. Here's another example. Let's expand 2a plus 3b to the 5th power. In this example, 2a is in place of x and 3b is in place of y. The rules for the exponents remain the same. We begin with 2a to the 5th, 3b to the 0, and then we have 2a to the 4th, 3b to the 1st, 2a to the 3rd, 3b to the 2nd, and so on. And the coefficient rules also remain the same. We're going to use the 5th row of Pascal's triangle, so the coefficients are 1, 5, 10, 10, 5, and 1. However, now we have 2a in here instead of just x. So we're going to have to simplify that. So 2a to the 5th times 3b to the 0, this goes away since 3b to the 0 is 1, and that 1 also goes away. 2a to the 5th is 32a to the 5th, because 2 to the 5th power is 32. So you just go through and simplify each term that exact way, and you end up with this.